गुड मॉर्निंग बच्चों। आज हम फर्स्ट ऑर्डर रिएक्शन काइनेटिक्स डिस्कस करेंगे। सपोज देयर इज अ रिएक्शन वेयर रिएक्टेंट A gives product B and this follows the first order reaction kinetics। तो इसका जो रेट ऑफ रिएक्शन हम लिख सकते हैं -dA/dt इक्वल टू K कंसंट्रेशन ऑफ A टू द पावर 1 दैट इज इक्वल टू KA। और इसको अगर हम इंटीग्रेट करें फ्रॉम से टाइम t इक्वल टू 0 व्हेन कंसंट्रेशन ऑफ A is A naught to any time t when concentration of A, that is the remaining concentration of A, is A. So we can integrate like this. With this equation I can write as dA upon A is equal to minus K dt. Okay, this differential equation I can rewrite as this. And if I integrate it from say concentration of A at time t equal to 0 to remaining concentration at time t, then it will be like this. And when I integrate it, I will get ln A from A naught to A means ln A minus ln A naught is equal to minus KT. Okay, and this I can write as ln A equal to ln A naught minus KT. So this is the equation that we have obtained after integration. अब इसको हम नेक्स्ट पेज में लिखते हैं. We will write this equation on next page. So the integrated equation is ln of A equal to ln of A naught minus KT. Okay. Now you see this equation is of the form y equal to mx plus c, where the slope is minus k and the intercept on y-axis is ln of A naught, that is intercept on y-axis. तो अगर हम इसको प्लॉट करें ln of A, that is natural logarithm of concentration of A versus time t, okay, then we will get a straight line like this whose slope will be minus k. Okay, this is minus k and the y-intercept will be ln of A naught. So this is the y-intercept and this is a straight line. So we can say that for a first order reaction, the graph of logarithm of concentration of reactant versus time is a straight line with slope equal to minus k. हमने जीरो ऑर्डर रिएक्शन में देखा था कि concentration of A versus time, that was a straight line with slope equal to minus k. So this is the difference between zero order and first order. First order में log of concentration of A versus time is a straight line. Okay, so sometimes this question is asked in past year questions that 4 options are given, that for a first order reaction, first option is that concentration versus time is a straight line. Second option is ln of concentration, that is log of concentration versus time is a straight line. And third option is concentration of A versus time is exponential. So we have to find the correct option. So this is not true because concentration versus time is straight line for zero order, not for first order. Second option is correct because log of concentration versus time is a straight line for first order. And third option is also correct because concentration of A versus time is exponential. Okay, so that behaves exponentially. So that we will find in the next. Okay. So this is how we can plot the graph of log of A versus time, which is a straight line. Now we will write this equation in different form. That is, if I write ln of A upon A naught, okay, because ln A minus ln A naught will give ln A upon A naught will be equal to minus kt, and this I can write as concentration of A upon A naught equal to e to the power minus kt, or I can write as concentration of A equal to A naught e to the power minus kt. So this is another form how the concentration of A varies with time. So if I want to plot concentration of A versus time, I will get this type of curve. Suppose this is the concentration of A, I plot for first order reaction versus time, then this will be the behavior of this. Okay, so this is varying exponentially because concentration of A is equal to A naught e to the power minus kt. So we can see that at time t equal to 0, concentration of A is A naught. So this will be at t equal to 0, concentration will be A naught. But it at t equal to infinity, if I see when time tends to infinity, the concentration of A tends to 0. Means we can say that the concentration will become 0 at infinite time, or we can say that first order reactions never go to completion. But we can say that first order reactions never go to completion. Okay, in zero order reaction we have seen that t lifetime when this zero order reaction goes to completion, that was A naught upon K, that is in zero order. But in case of first order, the t lifetime is infinity, or we can say that first order reactions never go to completion. So this is how the concentration of A varies with time for first order reactions. Okay, now sometimes they ask in the past year questions that how the concentration of B will vary with time. Okay, now we know that the concentration of B at any time t will be nothing but concentration of A naught minus remaining concentration A. क्योंकि जितना हमारा इनिशियल कंसंट्रेशन था A का, उसमें से जो रिमेनिंग कंसंट्रेशन ऑफ A अगर हम सब्ट्रैक्ट कर दें, then we will get the concentration of B. Okay, so this will be nothing but A naught minus A, I can write as A naught e to the power minus kt. So this will be nothing but A naught into 1 minus e to the power minus kt. So that is how the concentration of B varies with time. Okay, this also I can plot with time, that is concentration of the product, how it varies with time. I can plot as, suppose this is the concentration of product and I want to plot it with time, then this curve will be somehow like this, will be like this. Okay, so we can say that this is the concentration of B, which is nothing but A naught 1 minus e to the power minus kt. Now you see that at time t equal to 0, if I put, I will get B equal to 0 at t equal to 0, because 1 minus 1 is e to the power 0 is 1, so 1 minus 1 0, so concentration of t will be 0 at T equal to 0, concentration of B will be 0. So here at T equal to 0, concentration of B is 0, and as time T tends to infinity, okay, then this will be 1 upon infinity, that is 0, and concentration of B will tend to A naught. Okay, so we can say that this, if I plot, this will be the concentration of, this is A naught. Okay, because when time T tends to infinity, this term will become 0 and concentration of B will become equal to A naught. Okay, so this is how the concentration of product varies with time, and the concentration of reactant was how it varied, that we had shown in the previous graph. So that is how we have shown how the various graphs are for first order reactions. Now we will again write that equation, which was ln of A naught upon A equal to Kt. That was the formula. Okay, now this I can write as time, if time equal to 1 upon K ln A naught upon A. Now if I convert ln to log 10 base, I will get 2.303 upon K log 10 base A naught upon A. And this is the formula which normally we use for all our numericals. Okay, so time required for the concentration of A to become, the remaining concentration will become A after time T, we can say that. Okay, suppose we start with the initial concentration A naught, then the concentration will become A at time T or after time T. So this is the formula which we will use for our subsequent analysis. Suppose I want to find the half-life for फर्स्ट ऑर्डर रिएक्शन. तो हाफ लाइफ में क्या होता है, हमारा जो रिमेनिंग कंसंट्रेशन है वो क्या हो जाएगा, A naught by 2. Okay, because 50% completion of reaction means the remaining concentration will be half of the initial concentration. So we can put into this formula and we will get T half, that is half life, equal to 2.303 upon K log of A naught upon, instead of A I will write A naught by 2. So this will be nothing but 2.303 upon K into log of 2. Okay. Now the value of log 2 is 0.303. So if I put this value, then I will get T half equal to 0.693 upon K. So this is the half life for first order reaction. हम देखते हैं कि हाफ लाइफ डज नॉट डिपेंड ऑन इनिशियल कंसंट्रेशन, इट डिपेंड्स ओनली ऑन K. जबकि जीरो ऑर्डर रिएक्शन में जो हमारा हाफ लाइफ था दैट वाज A naught upon 2K. This was for half life for zero order reaction, which was directly proportional to the initial concentration. But in case of first order reaction, half life is independent of concentration. Okay. Now suppose I want to find out what is the time required, for 75% completion of a first order reaction. So we can say that 75% completion means the remaining concentration will be 25%, that is A naught by 4. Okay, because remaining concentration will be 25% of initial concentration after 75% completion. Okay, so we can write A equal to A naught by 4. So what will be the time required for 75% completion? We can put into that formula, that is 2.303 upon K log of A naught upon A. That was the formula. तो इसमें हम A की जगह A naught by 4 रख देंगे. So we will get 2.303 upon K log of A naught upon A naught by 4. So we will get 2.303 upon K into, this will become log 4. Log 4 I can write at 2 log 2. So into 2 log 2. And we know that the half-life was 2.303 upon K into log 2. This was the half-life. So T 75% I can write as 2 times T half. So for first order reactions, we can say that time required for 75% completion is 2 times the half-life. That is 2 times that for 50% completion. With this, I think we have completed our theoretical analysis. अभी लास्ट में हम एक बार सारे ग्राफ्स ड्रा कर देते हैं फॉर फर्स्ट ऑर्डर रिएक्शंस. पहला था हमारा रेट इक्वल टू के इंटू कंसंट्रेशन टू द पावर ए. ओके, देन सेकेंड ग्राफ वाज ए concentration of A, how it is varying with time. This was there. Then we have derived that concentration of B, how it was varying with time, that is A naught into 1 minus e to the power minus kt. Then we had written that ln of A equal to ln of A naught minus kt. तो ये सारे हमने फार्मूले डराइव किए थे. तो इनके बेस पे हम अभी ये कर्व्स ड्रा कर लेते हैं. सो फर्स्ट कर्व इज, वी कैन से रेट ऑफ रिएक्शन, हाउ इट वेरीज विथ concentration of A. So it will be like this, rate equal to K into A. So where slope equal to K, that is rate constant. So this is the curve for rate of reaction versus concentration. Okay, so higher the concentration, higher will be the rate, because rate is directly proportional to the concentration of reactant. अगर हम concentration of A versus time ड्रा करें, then how it will vary? It will vary like this. Okay, at t equal to 0, the concentration is A naught. So we start with A naught, and this will never go to completion, because at t equal to infinity, this A becomes 0. Concentration of A will become 0 when time tends to infinity. So we can say that first order reactions never go to completion. इसी तरह से अगर हम concentration of B, that is product versus time, plot करें, so what will be this? At t equal to 0, concentration is 0. Okay, and this concentration here it is 0. Okay, at t equal to 0, this formula we are applying. At t equal to 0, concentration of B will be 0, and it will be like this. Okay, and we can say that concentration of B tends to A naught when time tends to infinity. क्योंकि when t equal to infinity अगर रखें इसमें हम, तो 1 minus 1 upon infinity, यानी 1 minus 0, so it will be 1. So concentration of B will become equal to A naught when time t tends to infinity. So ये जो है यहाँ पे A naught कहीं आएगा, and it will never reach A naught, because it will never go for completion. We know that first order reactions never go for completion. अब लास्ट ग्राफ जो था हमारा, that was कंसंट्रेशन ऑफ ए का log लें अगर हम ln of a versus time, then it will be a straight line with slope equal to minus k, and y intercept will be ln of a naught. I think these are the various graphs which are there for the first order reaction. अभी हम इसका सब theoretical aspects we have covered. In the next session we will take all PYQs based on first order reaction kinetics. I wish you all the best and thank you.